RIP, the Routing Information Protocol, is a dynamic routing protocol that can be implemented easily on small networks when static routing is difficult to configure. It is a generic protocol supported by many platforms, vendors, hardware, and operating systems. RIP version 1 is classful, which means it cannot do discontiguous VLSM or variable length subnet mask networks and does not transmit subnet information. It only supports IP routing. Unlike RIP version 1, RIP version 2 does classless routing, or prefix routing. It will transmit subnet information so all devices on the network need not have the same subnet mask, and therefore VLSM can be implemented. RIP is known as a distance vector protocol. As such, it uses a hop count to judge distance. This means it uses a simple metric and sends the entire routing table to directly connected neighbors. This technique is called routing by rumor. By default, RIP uses broadcasts that send the routing table out every 30 seconds. This generates a lot of traffic on the network. Consequently, RIP is one of the least efficient of the dynamic routing protocols. RIP also has one of the highest administrative distances, or ADs, of all dynamic routing protocols, 120. The administrative distance functions as a measurement of a protocol's efficiency, and protocols with a lower AD will be preferred over those with a higher AD. The routes of lower AD protocols override any routing table entries made by higher AD protocols. Examples of protocol administrative distances are RIP with an AD of 120, OSPF with an AD of 110, IGRP with an AD of 100, and EIGRP with an AD of 90. Another disadvantage of RIP is that it is prone to pinhole congestion since it uses only a simple metric. If there are two links with the same hop count, but one link is much slower than the other, RIP will not take advantage of the faster link. Another disadvantage of RIP is that its convergence time is slow. Convergence time is the amount of time it takes all the routers to advertise their networks, neighbors, and adjacencies, and learn about the networks, neighbors, and adjacencies of the other routers. With RIP, all of this is broadcast-based, so the traffic generated can be intensive, and it can take several minutes for routers to learn about other networks. In addition, RIP has a maximum hop count of 15, after which a packet is taken off the network. This maximum hop count makes it impossible to use RIP on large networks with more than 15 subnets, since any packet distant beyond that would be incremented to a hop count of 16 and taken off the network. Here are some basic default RIP timers. The route update takes place every 30 seconds and is the interval between routing updates. Route invalid takes place every 180 seconds, and it's the interval for a route to be determined as invalid. The route hold-down is also 180 seconds, and that's the time during which routing information is suppressed. Finally, the route flush timer is 240 seconds, and that's the interval for a route to become invalid and be removed from the routing table. Many of these default timers can be revealed with the show interface and show IP protocols commands. When using RIP on Cisco routers, a useful command is passive-interface. This command prevents RIP broadcast from being transmitted out the specified interface. The RIP broadcast may still be received. This can help to reduce RIP's broadcast traffic on networks where it is not needed. Here's an example of how to use this command. From user mode, go to privilege mode with enable. From privilege mode, go to global configuration mode with config-t. From global configuration mode, go to router configuration mode with router RIP, and in the router configuration mode, simply specify passive-interface and the name of the interface you wish to make passive. Now let's set up RIP version 1 on our previously statically routed network. First, we need to remove our static routing entries with no IP. We've looked at setting up static routing and configuring a gateway of last resort, and now let's take a look at some dynamic routing protocols. Probably one of the simplest and easiest to configure, albeit possibly least efficient, dynamic routing protocol is RIP, a routing information protocol. And for a small network, it's appropriate. Now, for larger networks, we would want to use a more efficient protocol like OSPF or EIGRP, something like that. But on a small network, that's fine. So let's see how we would set that up, or how we would configure that. And the first thing we want to do, if we're going to use a dynamic routing protocol, let's get rid of all these static routing table entries. And let's just pretend we never did this. And I'm going to go ahead and video this so you can see how, once again, how would we remove routing table entries in the IS. So enable to go to privilege mode and config-t to go to global configuration mode. Well, actually, while we're here, let's do a show IP route. And we're on our perimeter router on our stub network. And here's our gateway of last resort. So let's remove that. So I'm going to go global, going global. And I want to do, in this case, no IP route. And I want to select here my route of 0000, all networks, all masks. And the one that points to 199.207 and 20 and 2 there in this case. And then with that set, I no longer have a static route. So if I do, let me go down to privilege mode, and once again I'll do a show IP route. Now I just have two direct connections or two adjacencies. And I'm going to go ahead and exit. I'm going to go on my middle router. I'm going to pull out those routing table entries. And Kiwi, and use our show command, show IP route. And again, here are my adjacencies, direct connections. I need to pull out the two static entries here. Go to global configuration mode, and I'll simply say no IP route. And it was 199.207. We'll start at the lowest 10.0 Class C subnet. And it was pointing to or being sent to 199.207.21. I can tell that by the routing entry that's listed up here. And then I also want to pull out 50. I'll just hit the up arrow. And 50 was being sent to 42. So I need to modify both ends. 40 and 2. Okay. And again, I'll do Control Z and show IP route. And now I just have direct connections or adjacencies, no static routes. It's broken. I broke my static routing, my network. But that's okay because we want to do RIPs. Let's go here and Kiwi and enable and Kiwi and in privilege mode. Again, let's take a look at our routing table entries, and we just had a gateway of last resort set up. So go to global configuration mode and no IP route. I want to, oops, extra I there. No IP route, and let's remove it. 0000 all networks, 0000 all masks, and it was pointing to 199.207 and 41. Okay. Control Z for back down to privilege mode. Show IP route. So now, once again, we only have direct connections or adjacencies, and exit. Now our network is once again totally broken. We've removed all the things that made it work, but that's okay because we want to implement something completely new here. And just to verify that, if I hop on Artemis and I use the good old ping command, let's see if we can go to 199.207.10.1. That's a direct connection on the gateway, no problem getting there. Let's see if I can get to 21, which is an adjacency on the router. No problem there. Now here's where it's about to hit the fan. Now we're going to have problems. So 22, request timed out. And my packets won't make it any further beyond that because I no longer have static routing table entries and I no longer have gateways of last resort. So it's time for dynamic routing protocols to the rescue. And in this case, we want to configure RIP. And in order to configure RIP, we just need to use the router keyword or router command. Okay, and I'm going to go ahead and hop on the first router once again. And I'm going to go into privilege mode. Our password of Kiwi and global configuration mode. Config T. And once I'm in global configuration mode, I can use the router command. I'm going to go ahead and specify router RIP. When I do, watch how the prompt changes to config router. So now I'm configuring routing information protocol RIP, and all I have to specify is the network I want to advertise. The way RIP works, routing information protocol, it advertises networks that it knows, and it broadcasts it, and then the neighboring routers hear those broadcasts, and they populate their routing tables with entries that are being advertised by other routers, their neighbors that are next to them. And eventually, after a period of, say, 30 seconds to a minute, something known as convergence takes place. And when convergence takes place, that's when all the routers have advertised their networks to all the other routers, and all the routers have then learned about each other. Sort of like they've chatted back and forth or kind of gossiped a little bit, and so now they're all aware of each other, and they all know where to route traffic. And this all happens dynamically, automatically. You don't have to add static routing entries. You don't even have to configure a gateway of last resort. You don't even have to use a subnet mask, because RIP is a very simple dynamic routing protocol. It does classful routing, and by this, we don't supply a subnet address. Now, other routing protocols, yes, we might need a subnet mask, but not with RIP. So the only network I need to advertise on this particular router is the network that I'm connected to. So in this case, network 10 and network 20. Actually, we can do network 10 here. I'm going to do 199.207 and 10 and 0 is the only one that I have to advertise. Okay, and then at this point I can go ahead and exit out. I'm going to go ahead and do copy, run, start, save my router configuration, and exit. So RIP is going, it's running, it'll start advertising. Now my middle router, I need to go in and kiwi, enable to go to privilege mode, kiwi the password, config T, go to global configuration mode, use my router command, router rip, router rip, and in this case, I want to advertise the two networks that we're connected to. So, or actually, we're going to advertise three. We're going to advertise 20, 30, and 40. And it's going to be, let me do network 199.207.20 and 30.0 and 40.0. Boy, the middle router's got a lot of work, eh? But it's going to be advertising and broadcasting those three networks in this case. And I'll pull this down, and so 20, 30, and 40, 10, and then finally, this last router here will have it advertise 50, so that eventually they'll all be able to learn about each other. It's beautiful. It's like almost spiritual, man. So I'll go ahead and save the configuration here. Copy the running configuration to the startup configuration. And we'll exit out. And now I'm going to hop on the Valkyrie and do the same thing. Kiwi. Go to privilege mode with enable. Kiwi. And go to global configuration mode. And in this case, let me router rip. And when I router rip, I want to advertise network. Ooh, netrock. Network. Netrock. Yeah, netrock. Rock the net now. Network. 199.207. It's really late. It's 3 in the morning, and I'm doing router simulations. Why? Anyway, because I have no life. 199.207. You ever get like philosophical late at night? 50 and 0 is what we'll advertise here. And we'll go ahead and exit. And exit, or I could do Control Z, whatever. But and I'm just going to do copy, run, start. Save that configuration there. Goodbye, big, beautiful, awesome network. We'll miss you. All that wonderful static routing. And now we have the wonderful, not so wonderful, inefficient, broadcast-based fill up your network with traffic RIP protocol, but it is a lot easier to set up on the bright side. Now we just need to wait. You need to wait about 30 seconds to a minute for convergence to take place, so that all the routers can go out and broadcast what they know to their neighbors, and their neighbors can learn about it, and then they too can broadcast what they know to their neighbors. And they'll just talk. They'll sort of talk amongst themselves, and once they're done talking amongst themselves, they'll know about the other networks. So let's see. Let's hop on the first router here. And I'm going to go to privilege mode. And let's look at any routes that might have been added. Show IP route. And notice that it's learned already now of 3 new routes. And you see the R in front of it. It was added dynamically. Didn't have to add that entry manually or statically or even a gateway of last resort like we did before. These were all added dynamically via the RIP, Routing Information Protocol. It knows now where to find 30, where to find 50, and where to find 40. Okay? And let's see. Even on the router itself, we have a ping command. Woohoo! So let's see what we can ping. Let's try 199.207. And the convergence may or may not have taken place for all three routers. If it hasn't, we won't get our packets all the way across. But let's just try. We're on router A, so let's see if we can't make it to 31 and 3010. 31, direct adjacency. Oop, not yet. Okay. So let's exit out there. After waiting for convergence to take place, let's test our new RIP routed network. As my routers are advertising, it's taken several minutes. I've been pinging and I could get as far as this router, but I wouldn't make it over here or wouldn't make it over here to 50. So it's really taken probably about 120 seconds, over 2 minutes, maybe even 2.5 minutes for total convergence to take place using RIP. But let's go ahead and test it now and see how far we can get. And basically, you have to kind of wait long enough, but eventually as all these routers dynamically learn via broadcast about their neighbors and other networks, they'll be able to route packets accordingly. Until that time, you're not going to get your pings all the way through. So let's go ahead and do ping, and I'm going to do 199.207.10.1. Again, that's just immediate default gateway there, no big deal. Let's do a direct adjacency, so 21. Let me get our echo replies. I'll kind of slide this over here so you can see the command prompt. Let's go ahead and do 22, which, if we haven't dynamically learned by now all of the connections in the middle router, we won't be able to get our echo replies. And we have, so we can. So 2, now that I'm on that network, let me try a direct adjacency 31. No problem, get echo replies from 31. How about 3010, which is the other side of that network over here, Apollo. And Apollo is sending back 4 echo replies. And now what about another direct adjacency on that router? Should have no problem reaching 41. In this case here, 41. And we get our echo replies. And now let's try to reach the other side of that network, 42. And we get our 4 echo replies. Now let's try to reach a direct adjacency on that router, 51. 51. And request timed out. Haven't got that far yet. Okay. So again, we'll kind of, let's go and check out 41. 41. 42. 51. There we go. Now we got 51. Got echo replies from 51. And now let's see if we can reach the other side of 51 here. So we'll try 10. 11. 12. And 13. Again, you'll notice that static routing was a lot more responsive and efficient, but also a lot more trouble to set up. And if you're willing to wait and you don't mind the extra broadcast traffic, RIP is a simple, easy to set up dynamic routing protocol that is ample on small networks. Let's take a quick peek at some RIP version 1 traffic to see what it looks like. Last, why don't we just take a look at some of the RIP broadcast traffic being generated as our routers continuously advertise their networks and their neighbors continuously learn about their networks. So I'm going to input the password kiwi, enable to go to privilege mode, and password kiwi. And some of the commands that I can use, I can do show IP protocols. In this case, and this will show me that RIP is sending updates every 30 seconds. And you can change a lot of these values here, but this is just a default every 30 seconds. And it becomes invalid after 180. Hold down 180, flushed after 240 seconds, and then once again it goes back to a learning state to see whether or not anything has changed or something changes. I can use that command, show IP protocols. I can also do show protocols, and that'll give me just sort of a summary of what's going on. Hit the up arrow a couple times, show IP protocols once again. And another useful command, if I do debug IP RIP, this will actually show me, now you can actually see what's going on. You'll see the broadcast traffic. RIP sending update, in this case, through serial, the serial connection 000, building update entries from other routers and networks it's learned about through its neighbors and adjacencies, and it's setting the metric, in this case, building update entries. And then if I wanted to turn that off, I could simply use the command undebug all. Here comes another RIP broadcast 30 seconds later. You can see that. And I could say no, or excuse me, undebug all would be an easy way to turn that off. That way I won't be getting, it's still going on, it's still happening, but that way it doesn't clutter up my console if I don't want to look at it or I don't want to see it.